Okay, so we want the volume under a surface and above this ring here. So again, what this tells us is we want to integrate this function, and the region that we're going to be integrating is going to be given by this region here. Now, this ring, this is a washer between the circles of radius 1 and radius 2. So this tells us that r will go from 1 to 2, and theta will go from 0 to 2 pi. Now, if you're confused about what I'm doing here, I would suggest sketching this region, and then maybe this stuff will make more sense. And then remember, we always write r dr d theta, and we want to integrate this function. We want to integrate this function over this region. If we change this to polar coordinates, x squared plus y squared is r squared, so we take the square root, and this is what we're going to be integrating. Okay, and now this isn't so difficult. This is just going to be equal to 2 pi over 3 times 7. So you just do these two integrals. These are just two Calc 1 integrals. Okay, so this integral is not a polar region integral, because we're not a polar coordinate integral, because we're not integrating over a circular region. So let's see what it is that we're integrating over. Let's look at the region that we're integrating over. So let me draw the xy axis here. Okay, let me draw the bounds for the region. Okay, so one of the bounds is going to be the line y is equal to 2x. That's this line right here. One of the bounds is going to be the line x is equal to 10. That'll be this line right here. And one of the bounds is y is equal to minus 1. That's what this bound is right here. Okay, and so the area that is enclosed by these shapes, I need to extend this a little bit like that. The area inside this triangle, that's the region that we're going to be integrating over. And now we just need to figure out how to do that. So the first thing is that we want to figure out what the y and x limits are. So if I want to have an x integral on the outside, I'll do the other way around in a minute. So if I want to have a y integral on the outside, what this means is that for every fixed value of y, or x, for every fixed value of x, we're going to be integrating vertically like this. Okay, so this means y is going to go from minus 1 up to this line right here. And this line right here is y is equal to 2x. So it's going to go from y is equal to minus 1 to 2x. And now I need to figure out what the x values are. The x values are going to go from this point all the way over to this point. Okay, now this line is y is equal to minus 1, and this line is y is equal to 2x. So we need to figure out this intersection point. So this is going to intersect when minus 1 is equal to 2x. In other words, when x is equal to minus 1/2. So the lower limit in the x integral is going to be minus 1/2. Okay, and the upper limit is going to be this point right here. Well, that is this line right here, this vertical line right here is the line x is equal to 10. And so we're going to put a 10 right here. And this is the function that we're integrating. So actually, don't forget the dy dx. So dy goes first because the y integral is on the inside. Dy dx x squared plus y squared. And this is equal to the integral minus 1/2 to 10 of this function here. Okay, so now this integral, this is just, again, a Calc 1 integral. Let's see, minus $64,113 over 32. I just did all of that in my head. I just did all of that in my head because I'm just so good at arithmetic. I'm just kidding. I used Wolfram Alpha. Okay, so the next part of the question is what happens if we switch the order of integration. So instead of integrating with the y integral on the inside, we're going to integrate with the x integral on the inside. So that means we're going to be integrating, we're going to fix a value of y, and we're going to integrate in this way. Okay, so let me come down here. This is going to be the x integral. Well, the x integral is going to go from this diagonal line. So if y is equal to 2x, so the equation of this line is y is equal to 2x, which means x is equal to y over 2. So this is going to be x is equal to y over 2, all the way over to this right line. This right line here is x is equal to 10. So x is going to go from y over 2 to 10. Okay, now the y values are going to go from this bottom line, which is minus 1, up to this point right here. So the bottom limit on the y integral, the bottom limit on the y integral is going to be minus 1. And the top limit on the y integral is going to be where these two lines intersect. So this is x, the vertical line is x is equal to 10. The diagonal line is y is equal to 2x, or x is equal to y over 2. So this is going to be y over 2 is equal to 10. So in other words, y is equal to 20. So this is going to be up to y is equal to 20. And the function that we're integrating is still x squared plus y squared. Just like this. Okay, and that is the answer to the second part of the question. Okay, so really the big thing in this problem is switching the order of integration. So the first integral that we have, this is not that difficult of an integral to do. It's just equal to 18. This is just the kind of integrals that we've been doing for a long time, and it's just essentially two Calc 1 integrals. So this is a 2y. Okay, now the new thing is switching the order of integrations. So I think first we need to sketch what this region is going to look like. So if you look at the x integral, x is going to go from the line x is equal to y to the line x is equal to 2y. So the bottom limit is going to be x equals y. So let me graph that. In the xy plane, the line x equals y is the same as the line y is equal to x. So this is y equals x. Okay, and the line x is equal to 2y is the same as y is equal to x over 2. So that's going to be like this line. So this is 2y, or sorry, I'll say y over y is equal to x over 2. Okay, and we're going to integrate up to the line y is equal to 2, which we'll say is this line right here. Okay, so now if we want to switch the order of integration, this means that we want to have the y integral on the first, in the first integral. Okay, so now notice something is different something aggravating is gonna happen here. When we integrate to the left of this blue line, we're gonna go from this line y is equal to x over 2 to this line y is equal to x. And then after this, to the right of this blue line, we're gonna integrate from y is equal to x over 2 to y is equal to 2. So we're gonna have to, to split up this problem into two different pieces depending on where x is. Okay, so for this first piece, y is going to go from x over 2 to x. Okay, now what values of x is this valid for? This is going to be x equals 0 to this. So how do we figure out the coordinate of this top point? Where it's going to be where y equals 2 intersects the line y is equal to x. So in other words, it's going to be 2 is equal to x. So this is going to be 2, and then we'll have the function that we're integrating, 3x y dy dx. Sorry, let me try to make that look more like a y. That's a y, even if it doesn't look like it. And now for the next integral, the y limits, remember the y limits are going to now go from x over 2, this line, to this line. Okay, over here it went from this line to this line. Here it went from x over 2 to x. Now it's going to go from x over 2 to 2. So now the y integral, we'll look at the y limit first. The y integral, or the y integral first, the y integral is going to go from x over 2 to 2. And now the x integral is going to go from this point to this point. Well, this point we saw in the last point, we saw in this part, the x coordinate of this point is 2. Now we need to figure out what the x coordinate of this point is. Well, this is the line y is equal to x over 2. This is the line y is equal to 2. So this point right here is going to satisfy 2 is equal to x over 2. So that's going to be 4. And now we have to put the function that we're integrating, 3xy dy dx. So clearly for this problem, doing the integral the way that it's given is way better than doing it in the other way, because if you do it with the y integral on the inside, you have to split it up into two pieces. And let me just remind you, the way that we figured out the coordinates for this point right here, the way we figured out the x value for that line and that line, we just used the fact that the x coordinate was the intersection of these two lines. This is y is equal to 2. This is y is equal to x. And similarly over here, we just found the coordinates for the intersection of these two lines, the line y is equal to x over 2 and the line y is equal to 2. Anyway, so clearly doing the integral the way that we are given is the best way to do this integral.